All right, I kind of want to just be like, are you ready? It's like after lunch. So I'm going to keep it, we're going to come on in, take a seat, folks. My name is Elise Neel, I'm from Verizon, and I have the opportunity of managing a team called New Business Incubation. And at New Business Incubation, we are responsible for building new software businesses that are powered by the 5G future. And today I'm going to talk with you a little bit about how we see the 5G future kind of orienting and helping to propel new business outcomes in Industry 4.0. So we're going to dive right in. For those of you who are not familiar with Industry 4.0 or what that term means, it's a little bit like the word gourmet. It's kind of like the definition is in the eye of the beholder. So I thought we would just level set today and talk about the four main criteria for what does Industry 4.0 mean. You'll see those down the left side. It effectively is a combination of physical, digital, and biological structures. It's massive information transparency. We look at high degrees of technical assistance, and then major decentralized decision-making. When those four characteristics appear in major industries like warehousing and supply chain and energy and mining and logistics and construction, we see today that there are discrete product elements that are showing up that give us a wink and a nod to maybe one of those specific criteria. We see the development of cybersecurity and cyber intelligence. We see massive cloud computing as we think about decentralized decision-making. We look at augmented reality as a way to kind of blend the physical and digital structures, etc. However, the promise of Industry 4.0 is actually the combination of those things. It's a fully autonomous, self-improving process that assigns the right work to kind of the right set of tasks. And we have yet to really see that happen at scale. And you might ask yourself, like, why is that? So in a recent study, about 100 Industry 4.0 executives were surveyed about their level of excitement and what they believe is going to be the promise of Industry 4.0. And they're like pretty pumped up. Like, listen, 93% say we are going to get massive productivity gains when we now have the delivery of Industry 4.0 technology. We're going to get huge improvements in quality, and our workforce are even going to be more enabled and more excited because now they won't have to do dull, dirty, or dangerous tasks. And so we're like, sweet, there should be huge adoption. However, when you ask those same executives, where you at? Where you at in your Industry 4.0 journey? Cloud computing has been around for a really long time. Augmented and virtual reality, some of these tools are not brand new. We see that less than 10% of them have actually fully adopted any major kind of digital transformation yet. In fact, a third of them are still kind of in the dabble stage. They're doing kind of ad hoc implementation. So if the technology is available, if everybody's pretty pumped up about it, like, what's the problem? We see that there are 5 main pain points that customers are struggling with in their digital transformation journey. We particularly focus on manufacturers since it is a particularly challenging part of the industry framework. First, if you can imagine yourself as a kind of plant manager or a line manager in a manufacturing facility, whether it's you're manufacturing robots or you're manufacturing big pens or you're making clothing items, they have a wide variety of different hardware that's available on site. That hardware is typically delivered in a vertically integrated stack. If you're in automation, Siemens produces a vertically integrated stack with Siemens software, hardware, and networking solutions that happen to not talk or interoperate with those from Rockwell or ABB or others. And so you have created silos as each company has tried to kind of go out and provide their portion of the automation journey. In addition to that, much of this equipment is sometimes 10 to 15, even 20 years old. So this idea that you're going to go in and you're like, you know what you need? I'm going to take everything out and I'm going to replace it with magic for the future. It's just not interesting. The capital investment is too big. There's legacy protocols. They're not kind of using the same coding languages that we oftentimes use today. And so that provides another material barrier. In addition to that, data sources are fragmented. I was just recently on a manufacturing facility. The number of steno pads and like mechanical pencils I saw, it just like rocked me to the core. But it works for them right now. It's just not terribly efficient. So they're literally like, okay, well, Bobby on the whiteboard, he's in aisle number 7, and Susie is on aisle number 2, and that's how they run their business. It is not unique. In addition to that, when they look to implement technology solutions, particularly on the networking side, because if you're going to have a digital environment, if you're going to have sensors, you're going to need a network to do that. Most of these are incredibly hostile environments. There's metal, there's glass. These are no bueno for networks. Whether it's a Wi-Fi network, a Bluetooth network, or a cellular network, the ubiquity of that signal does not exist. But once they get pumped up about the sensor components, and they start censoring all the things, because that's what they need, they just need to censor everything. They're like, I don't know what to do with the data, it's too big, I don't know how to make sense of it, not all of it is important to me, and like herein lies the problem. So they kind of compound over and over and over again. So we've been thinking a lot about like how do we help customers kind of shepherd them along their digital transformation journey, because we're not going to take those 5 problem statements and then like magically, there's like one stop shop solution. It's too complex, it's too fragmented. And so instead, we believe that there are kind of 4 main stages that the average customer in Industry 4.0 goes to. First is the toe dip. They're like, all right, I gotta de-risk, I gotta kind of enter in for like low adoption. I already hung some cameras, somebody sold me some tech. Can you do more with what I already have? I'm trying to prove to my CFO that this is really going to pay off, that the digital investment, my capital investment, is going to produce more yield. So how can you use what I already have, but just make it smarter? Here we're deploying new AI models, new computer vision models. We're doing a lot with sensors and video intelligence, because most places have some of those elements already today. And then they get hooked on phonics. They're like, that was the gateway drug. Now, I want to do more. They've seen their ROI and they're ready to implement it more broadly. But they're like, I don't know that I want to turn off or shut down my manufacturing facility in order to implement a new network design, or to implement a new standard operating procedure, or to introduce some element of automation. So like, how do I know it's going to work before I spend the $20 billion or $20 million or $20,000 before I kind of implement that? So they want you to simulate it. Can you introduce simulation models and digital twins? Can you tell me what's going to happen in some different environment before I kind of rip and replace? Then they're like, okay, sweet. You showed it to me a little bit in real life by using existing equipment. Now you've shown me what it looks like in a digital environment and all the magical things that are going to happen. Now I'm ready to implement. They implement automation components. Maybe they automate one line or one portion of the facility, but they very quickly realize that they need to automate the automation. That the automation is not built for interoperability or interconnection or inter-design. It's not integrated into standard operating procedures. It really is automation in a silo. And so we see there that there's a new opportunity to create a single pane of glass, to automate the automation. And then like the grand poobah, the big end, this is autonomy. Here they're like, how do I do self-healing, self-performing kind of sets of tasks? How do I continually learn in that loop? The things that frankly for the last few days we've been talking a lot about. So we believe that there are 2 core elements that will help to push customers along this journey, that will help kind of revolutionize Industry 4.0. One of them is 5G. Now, in case you have not lived for like the last few years, we telco people are like pretty fired up about 5G. I'll tell you why. One, it is a completely different everything to the network. It is a brand new protocol and design and implementation structure that has no legacy and no past. This is all together new. A couple fun facts for you, again, in case you've been living under a rock. It has speeds and bandwidth, the fattest of the fastest pipes you've ever experienced ever in technology, 10 times faster than what you experience today in LTE. You're like, okay, that's cool, that's a lot of data, but like, how fast is it, Elise? Well, it's up to 100 times faster than the blink of an eye. We have seen, I physically, personally experienced 5 milliseconds or less of latency. It will literally blow your eyelashes off. It's unbelievable. You're like, and then everything happened. It's remarkable. And then when we think about density of devices, today in the average LTE network, you can support about 1,000 connected devices per square kilometer. I'm like, that's pretty cool. That's a lot of data and a lot of throughput. But in a 5G world, that goes to 1 million devices per square kilometer. The densification and the ability to think about processing all that data in a relatively small geographic space is pretty exciting. But it's not just about the rails. It's not just about the network. Because the network itself actually isn't a product. The network is a capability. It's about what do you do with the network. Okay, here comes, this is what I get to do all day, the software side. So what we have organized is thinking about these problem statements in Industry 4.0, and how are we going to take these individual discrete elements that are available to help solve a point problem and actually begin to stitch them together to move the industry kind of forward de-risking change all the way to introduction of autonomy. So what you see here are three main kind of red components that we believe every major customer throughout their digital transformation journey in Industry 4.0 are going to need to answer. First, you're going to need to answer what is happening in a space. They need to sense what's happening and they need to create context to that. What is happening? Where is it happening? Help me understand everything from digital twin to precise positioning to sensors and LiDAR data to IoT data, etc. Help me manage and sense and understand what's happening in that space. And then they say, okay, great, now I need to know what's going to happen next. So help me predict and simulate and understand all of those next generation components, simulation engines, major AI behind that, connection into ERP, WMS systems, CRM systems, etc. Help me combine those elements together to help me predict the future. So now if I understand what's going on in the space, I know what's happening and where it's happening, and I know what's going to happen next, then I want to do it. I want to do command and control. I need to make it happen. And across the bottom, we have a wide variety of ecosystem partners and direct operated kind of assets that allow us to create those action sets, whether it's aerial robotics or autonomous forklifts or a solar array or an HVAC system. Those connections into creating that kind of full-rounded autonomy are important. But the glue, the stitching that binds it together, is the applied sciences. It is the AI and machine learning. It is the understanding of where does the compute sit? The 4G network was built for download, streaming data, downloading big attachments, thinking about how do we access more from the internet. The 5G network is built for upload. Think about that. Totally different protocol, totally different use cases. And an average drone flight, 20 minutes long, it's about 2 petabytes worth of data at a 4K rate. How are you going to get that up there, process it, and then take probably 2% of that data and apply it down to the analytic that you actually need, right? The whole network orientation is different. Where the compute happens is different. Is it on device? Is it on the edge? Is it on the network? Is it on the network edge? Is it on the cloud? Is it on the near cloud, the far cloud? Like we got a dozen different options of where the compute happens. So all of these things we get really excited about because it's not just about the network, it's about the software and that combination of those elements kind of coming together. So I want to show you an example. You guys want to see something? I'm so glad. I'm so boring. Yes, I knew it. I knew you did. Okay, I'm going to set this up for you. So here's what we have. I'm going to walk you through a use case that is a security use case. Here we have a physical building, a physical security use case, and a common problem that we have is when there has been a suspicious package or a vehicle that has been parked for more than 24 hours kind of outside the building. We don't know if there's somebody who is in duress. We don't know if it's a medical emergency. We don't know if it's nefarious activity. We don't know. And so traditionally what happens is maybe there's a camera that says like, hey, I think this car was here yesterday. I don't really know. Susie, go check it out. So Susie straps up, she goes up, she kind of figures it out. She writes up a report, she comes back. Maybe somebody's doing eyes on it at the same time. Maybe they call the police for backup, but it's about 10 different steps of manual processes coming together. What we're going to show you is an example of sensing and understanding what's happening. How do I simulate what's going to happen next? How do I mission plan? And how do I execute a mission over the network? How do I use command and control 100% written over the 5G network, pulling down AI models referenced from the cloud in near real time? So, one collab, here we go. All right. So in this video, you're going to see camera number 3 will light up here. Camera number 3 is going to say, hey, listen, I've detected that there's this vehicle that has been parked for more than 24 hours. I've streamlined all of that footage, and now I know I want to go take a closer look. Automatically, using the stitched together intelligence, because everything is in the cloud, it automatically deploys, in this instance, a Boston Dynamics spot robot. We're using all of the command control from Boston Dynamics that has been put into the cloud and is being delivered 100% over the network versus with some kind of remote control. And we are using our location intelligence to say, this is where you go. Because the robot doesn't know where to go until you tell it where to go. Now the robot is stupid. Most of them are. They're just machines. They don't have any intelligence. You have to tell them what to do. So it reaches its destination and it's like, what is this thing? Is it a dog? Is it a human? Is it a Maserati? Is it a Tesla? I don't know what it is. And so as it circulates around the vehicle, it's going to build a reference set, the digital twin, in real time. As it's doing this over the network, it's saying in every single image, what does this look like? Something like this looks like something else I've seen before. And it's using that reference set to build the 3D model in real time. As it's doing that, and as it's building that reference set to say, hey, we think that this is a Toyota Tacoma specialty car, I don't know, TRD, one of the fancy ones. It's saying, well, what should we do next? Now that we know that it's a truck, how do we inspect a truck? A truck has different components and different physical elements than a two-door sedan or a minivan. And so here it's now building those elements all the way around. You'll see first the robot begins to look inside the cabin. You'll see it on the right-hand side, kind of what's in the criteria that it's going through, kind of that check the box components through the orientation. There's no human in the vehicle. There's nothing that kind of brings up about a problem. It looks in the undercarriage of the vehicle. Is there a package here? Is there a suspicious element? Is there loose wiring? Is there an oil leak? And what are all of the good and bad things that one could find underneath the bed of a truck? As it does it here, you'll see that it also kind of clears this component. And it's using real-time computer vision analytics to understand kind of how do I diagnose what's happening in that space. It does a little dance, and now it goes into the truck bed. Now again, some vehicles, this looks like an insert into the back of a hatchback, but the orientation of the size and the scope, how to angle the camera down to get a good view is interesting. It notices that there is a package and it says, what do I do next? It uses intelligence over the network to download a FLIR detection component to do an analysis around thermal imaging. Bombs or other kind of activities would represent themselves differently, but thankfully in this case, we're all good to go. Here, all of the analysis, all of the real-time streaming footage is provided to anybody in a collaboration environment. Needless to say, the safety individuals or the security individuals who are safely back inside the building, and then it returns safely back to home. These processes use everything from location intelligence, sensor fusion, precise positioning, robotic command and control, digital twin, simulation, and a wide variety of open source available AI models that we can pull, organize, and stitch together using the power of the network in a 4-minute inspection exam. That's what we're talking about for the future. So, with that, I'm pretty pumped up. We're excited. We're just kind of getting started here as we think about what the future holds. But it's not just about the network, it's about what you do with it. And it's the intelligent way that we as a community work together to make sure that our future is safe, that it is ethical, that we use the power of the network in an intelligent way. And I can't wait to live this dream right alongside with you. If you have any questions, or you want to chit-chat a little bit more, or you want to pet a robot at one point, we'll meet outside and we'll go from there. But thanks for the time today, everybody.